Hello everybody. Today I can identify key information for exponential and logarithmic graphs by knowing the key pieces of information. So we're going to start with an exponential graph. We're going to look at different exponential graphs and see what they all have in common. Then we're going to look at different logarithmic graphs, see what they have in common, and compare the exponential and the logarithmic graphs. So it's a very conceptual lesson. It's about understanding the key pieces of information. There's really not a lot of calculations. It's just conceptual understanding. So let's go to the calculator. Let's go to y equals, and let's type in an exponential equation. So I'm going to type in 2 to the power of x, and I'm going to look at it. Oops, let me just bring back my regular window. Now, this is what we call the parent function of an exponential graph. This is what your standard exponential function looks like. So, we're going to take a look at some other exponential graphs and see things that they all have in common. So let's now do 3 to the power of x. And let's talk about what they have in common. So, let me just blow this up for a moment. Okay, so let's look at this thing. What do they have in common? Well, they both pass through this point right here. And every exponential graph will pass through that point right there. So we have y equals 2 to the power of x, and we have y equals 3 to the power of x. And what that point is 0, 1. Every exponential graph will pass through the point 0, 1. Every non-translated exponential graph. If it gets shifted, that can change. But every non-translated exponential graph passes through 0, 1. Why? Because if I put 0 in for x, anything to the 0 power is going to always be 1. So 0, 1 is going to be on every single non-translated exponential graph. What else do they have in common? Well, first of all, let me just explain this to you. You can't really see it in here. You talked this a little bit in Algebra 1. But these are getting closer and closer and closer to the x-axis, but never touching it. So what we call that, when something gets closer and closer and closer to a line, but never touches it, that's called an asymptote. And an exponential graph always has a horizontal asymptote. And if it's non-translated, its horizontal asymptote is going to be y equals 0. So it's getting closer and closer and closer and closer, but it's never touching. Think of it like taking steps towards a wall. If I take a step towards a wall that's half the distance to the wall, I'm never going to actually get to the wall. I'm going to get closer and closer and closer to the wall, but I'm never going to actually touch it because I'm going to always be half of the distance away. That's the concept of what's going on here. So, the domain of both of these is negative infinity to infinity. There's a graph out here, again, it's going on forever, it's getting closer and closer but never touching, and since there's arrows, there's graph all the way out to the right, so the domain is always negative infinity to infinity. The range, well, it starts at 0, but not including 0, and it goes to infinity. And these 4 things will be the case for any exponential, any non-translated exponential function. It's going to always pass through 0, 1. It's going to always have a horizontal asymptote at y equals 0. The domain is going to always be negative infinity to infinity. The range is going to always be 0 to infinity. So if I go back here and I add some new ones in, let's do some like fractions. Let's do 1/2 to the power of x. So that's going to be, since it's less than 1, it's going to be exponential decay. You'll see what that is in a moment. Let's say I want 2.7834 to the power of x. Let's say I want 2/5 to the power of x. No matter what the base is, all of them are going to pass through 0, 1. They're going to have an asymptote at y equals 0. They're going to have a domain of negative infinity to positive infinity. They're going to have a range of 0 to infinity, not including 0, because it has the asymptote, the imaginary line it's getting closer and closer to, but never touching. All right, now let's take a look at log graphs. Let's just clear these out. So my standard parent function is going to be log base 2. If you remember how to type log base in, it's alpha window 5. So let's take a look at log base 2 of x. Now this is similar but different to the exponential graphs. And let's just put a second one on here so we can compare them. And oops, that was not what I wanted to do. Alpha window 5, log base 2 of x. And let's do alpha window, alpha window 5, log base, it doesn't matter, let's do 3 of x. Let's look at the graph, and let me blow it up so we can see it a little bit more clearly. So here I have y equals log base 2 of x. Here I have y equals log base 3 of x. And let's see what they have in common. They both pass through this point. They both pass through 1, 0, and that will always be the case, and here's why. If you remember, when x is 1, this is saying log base 2 of 1, log base 3 of 1. And this is saying 2 to what power is 1. This is saying 3 to what power is 1, and we talked about that in the evaluating logarithms lesson. Well, anything to the 0 power is 1. So if I want to end up with a 1, the power has to be a 0. That's why it passes through 1, 0. Now I have an asymptote again, but in this case I have a vertical asymptote, and it's hard to see in here, but it's getting closer and closer, but never touching. So the asymptote for a logarithmic is x equals 0. Domain. Well, my domain, there's nothing in the negative territory here. My domain starts at 0, but not including 0, and then goes on forever. And my range, well, since there's an arrow going down, is negative infinity to positive infinity. So we're going to put all this into a table and compare it with the exponentials. And that's what we get right here. So this is your basic standard exponential growth function. This is your standard logarithmic growth function. Understand, though, that there's an asymptote here, and there's an asymptote here. It's getting closer and closer to that value, but never touching. Exponential has a horizontal asymptote. Logarithmic has a vertical. Exponentials is y equals 0. Logarithmic is x equals 0. Exponential passes through 0, 1. Logarithmic passes through 1, 0. Everything is opposite. Domain is all real numbers for exponential. Range is all real numbers for logarithmic. Range is all positive real numbers for exponential, whereas the domain is positive real numbers. Everything is switched because exponents and logarithms are inverses of each other. And it's important to understand that. Exponents and logarithms are inverses of each other. That's why, for the graphs, everything is opposite. Y equals 0 for exponential, x equals 0 for logarithmic. 0, 1 for exponential, 1, 0 for logarithmic. The domain is the range. The domain of exponential is the range of logarithmic. The range of exponential is domain of logarithmic because they're inverses of each other. And if I go back to my calculator and I type in an exponential and a logarithmic, 2 to the power of x, and then log base 2 of x. We mentioned it briefly, I believe. Yes, we did mention it when we did the inverse lesson. But graphically, inverses are a reflection of each other over the line y equals x. And if I snip this thing, you can see that if I draw in the line y equals x, it's a reflection of itself over that line. So basically, this is everything you need to know about exponential and logarithmic graphs. You can use your calculator for some questions, but you need to have these understandings because they may ask the question in a way where you have to understand this. Understand as well that they are inverses of each other. So if it's asking for the inverse of an exponential, it's a logarithmic. If it's asking for the inverse of a logarithmic, it's an exponential. We did a lot of talking. Let's do some problems now. Which equation best represents the accompanying graph? Well, the best thing to do for something like this is to just type it into the calculator. However, since it is exponential growth, the only one here that is exponential growth would be choice 1. But again, your best thing to do for an example like this would be to go to y equals. I filled this one in here. Look at it and see what matches up. If you type the other ones in, you'll see that they don't match up. Number 2, you know what? 2, 3. Try 2 and 3 on your own right now. Literally, you can try and do it without the calculator, but type them into the calculator, the choices, see which one matches up. So pause, complete 2 and 3, and then unpause. Okay, for number 2, again, the best way to take a look at this is to go through each choice. Choice 1, 2 to the power of x. Is that right? No. Choice 2 is negative 2, is negative 2 to the power of x. That does not look right. Choice 3 is alpha y equals enter, 1/2 to the power of x. That one looks good, and I'll just check choice 4. You should know that choice 4, because there's an x squared, it's a parabola, so that definitely can't be it. And it's not. Now, another reason I knew that choice 3 would be the answer is since the base is less than 1, that means it has to be decay, which means it's getting smaller. Growth, if it's more than 1, it's getting bigger. Decay, if it's less than 1, it's getting smaller. For number 3, this is one, again, you just need to type into the calculator. Now, I can eliminate a couple of choices right off the bat. I know that every single log graph has to pass through, where is it? Every log graph has to pass through 1, 0. So I know it's going to have to be choice 1 or 3. I know since it's a regular growth of positive 2 there, it's going to have to be my regular function, which is this. But again, I can go to my calculator, y equals alpha window 5, log base 2 of x, and I can look at it and see my answer. Now again, understand that it's hard to see in the picture, but there's an asymptote, and it's getting closer and closer, but never touching the x-axis, the y-axis. Now, number 4, I love number 4. This is more conceptual. You have to read it carefully. In fact, you know what? Why don't you take about 20 seconds, read it, come up with your answer, and see if you got it right. There is a little twist. Take about 20 seconds, give it a try. Okay. The answer is not choice 1, because it's not asking for which graph is f of x equals 4 to the power of x. It says which graph represents the inverse of this. Well, since this is an exponential graph, the inverse must be a logarithmic graph. So, which of these is a logarithmic graph? Choice 4, because you need to know that an exponential growth looks like this, and a logarithmic looks like this. It's about knowing what they look like and understand they're inverses of each other. So if it asks for the inverse of an exponential, you're looking for a logarithmic. 5, 6. Try 5 and 6 on your own right now. Try 5, 6, and 7 on your own right now. The way that 7 is phrased is a little confusing. So please pause. Try 5, 6, and 7. You know what? No, I want to leave you some stuff to do for homework. Just try number 5 on your own right now. Okay, so it's telling us that f of x equals, basically it's telling us we have a logarithmic graph. It's asking for the inverse. Well, the inverse of a logarithmic graph is an exponential graph. So which one is an exponential growth? Choice 1. And it's growth since the base of the log is 4, basically the base of the exponent is 4. That's it. I'll let you do 6 on your own later. Number 7, just a hint, because they switched x and y, it's asking for the inverse of exponential. We learned when we did the inverse lesson, inverse means switch x and y was switched, so it's asking for the inverse of an exponential. That's just a little hint I want to give you. Now the rest of this is these multiple choice questions where it's kind of just like, go through the choices and see what's true. And if possible, yeah, it'll be helpful to type the graph into the calculator, to type the equation to the calculator and look at the graph, but the intention is that you should be able to do it without the calculator. So which statement about the graph of c of x equals log base 6 is false? Well, it's a log graph. So I know that a log graph passes through 1, 0. I know that it has a vertical asymptote at x equals 0. It's getting closer and closer but never touching, and it looks like that. And again, you can always refer back to this if you need to. Now that I have that, I should be able to answer it from there. And again, if you need to, refer back to this. So, choice 1, the asymptote has an equation y equals 0. Well, since this is a vertical asymptote, this is x equals 0, so this is not true. The graph has no y-intercept. That's correct. There's an asymptote at the y-intercept, at the y-axis, so it never hits the y-axis. The domain is a set of positive real numbers. Yes, it's 0 to infinity. There's no negative numbers. It's not 0, so it's just positive real numbers. The range is all real numbers. Yes, the range goes from negative to infinity because there's an arrow pointing down. There's an arrow pointing up, which is false. Choice 1. And that's what you're going to have to do for these questions. You're just going to have to understand the components of the graph, refer back to this page if you need to. This is in the front of your packet as well. And then, answer the question based on that. You can type it into the calculator. Again, it's not wrong if you can type something like this into the calculator, type it into the calculator. That's going to help. But y equals e to the power of x. Again, e is just a number. It's going to pass through 0, 1. It's going to have an asymptote. It's going to look like that. So I don't need to graph it in the calculator. I just need to know what any exponential function looks like. So why don't you try number 9 and 10 on your own right now? Then I'll go over them, and then I'm going to let you practice this on your own. Try 9 and 10 on your own. So pause it, try 9 and 10 on your own, unpause it, I'll go over them, and then I'll let you practice on your own. Now that you tried number 9 on your own, which statement is not true? So let's see what's true and what's not. It's asymptotic to the x-axis. Yes, the x-axis is an asymptote. That is correct. The domain is all real numbers. Yes, the domain is going from negative infinity to positive infinity, all real numbers. It lies in quadrants 1 and 2. Yep, there's nothing down here in 3 and 4. It passes through the point e comma 1. It passes through the point 0 comma 1. Any exponential graph passes through the point 0 comma 1. So no, it doesn't pass through e comma 1. It passes through 0 comma 1. Choice 4 is not true. 10, because this value is less than 1, it's exponential decay. It still passes through 0 comma 1, but it's going to look something like that. And again, you can type this into the calculator. Which statement is always true? It's always increasing. When we talked about increasing, decreasing earlier in the year, it's like a roller coaster going from left to right. So this thing's not so much a roller coaster, it's a slide. It's always going down. So it's not increasing. It is always decreasing. It doesn't pass through 1, 0. It passes through 0, 1. The asymptote is not x equals 0. The asymptote is y equals 0. So which one is true? Choice 2. So the key to this lesson is this right here. It's understanding what they look like. It's understanding the key components and that they're inverses of each other and everything is backwards. Y equals 0 asymptote, x equals 0 asymptote. 0, 1, 1, 0. Domain is the range is the domain because they're inverses of each other. Your classwork/homework is to finish this. I hope everybody has a great day.